number 5. I'm going to record this, and I'll keep recording probably people who are online until after the bell rings if y'all need it. So number 5, they gave you triangle XYZ. Let's see. This is W, and they told you angle X was 36 degrees, angle Y was 49 degrees, and this whole length is 780. That's okay, I can explain it. So they're saying in class they already did this one. They like explained them to each other and helped each other check them while I was out. For this one, we want to find XW. So this piece right here. So I'm just going to call it A. We want to find that piece right there. Do you guys see a way that we could set up a proportion that would then enable us to find A? That would help us find A. Okay, good. If we find this angle up here, the top angle, couldn't I do the sine of that angle over 780 equals the sine of 49 to find this side? And then if I have this side, it's a right triangle, I'll have an angle and a side, which means I should be able to use SOHCAHTOA. Are y'all okay with that? Kayla, you okay, babe? Okay. So did you guys find the top angle? What did we find for this angle? What did we get? 95. Good, Grace. How'd you get 95?
I added 49 and 36 and then
Perfect. If you add the two base angles and then subtract them from 180, we should get 95 degrees. So now my people at home, I should be able to do the sine of 95 over 780. And then you need to use 49 for your next proportion because we need one of the sides in this smaller left-right triangle to be able to find this bottom piece. So equals sine of 49 over, are y'all fine if I just call this X? Okay. You guys okay with how I have that set up? People in class, y'all are good? People at home?
Good.
Okay. So then you cross multiply. You would get X sine of 95 equals 780 sine of 49. And then how would you get X by itself? Very good, Kevin. Divide by sine of 95. So in Desmos or in a calculator, you can type this in and it'll give you X, right? What's just going to be really important to do once I find X? Don't round it. We're either going to store it if we're using a calculator, or if we're using Desmos, we're just going to keep it up there in a box. We'll do all of our other stuff in a new box, and then you can copy and paste it. We don't want to round it, okay? Because this isn't the final answer. So if I type in 780 sine of 49 and divide that by the sine of 95, I'm getting for X 590.92. Is that what y'all got? Okay, it should be 590.92. That's what my paper up there says. And I'm not going to round to that though, so I'm going to put dot, dot, dot down here. And now I'm going to store that as X. Store as X. So it's in there. Y'all okay? I had a lot of you on your quiz. I will still go over quizzes. If that's what you want to do tomorrow instead of take your test in class, if you want to go over that, totally can. That's fine with me. But I had a lot of you, I think we're just dividing wrong, like we're using a calculator and weren't putting the parentheses in, or I'm not sure what happened. Because a lot of you, your work paper had it set up right, but then you got the wrong answer. So I think some people weren't in the right mode. But now we know what X is, so everybody look. This is why we needed to find this side. Now you have this green right triangle where you know one of the angles and one of the sides. So now we can use SOHCAHTOA. If it's a right triangle, and you know one angle and one side, you should be able to find the other pieces you and Zach could sew up, okay? All right. I'm gonna erase this part just so everybody can see how I'm gonna set this up. So based on this angle that we have, I want the adjacent side, and I know the hypotenuse. So adjacent and hypotenuse uses what trig function? Cosine. So you should do the cosine of 36 equals the adjacent, which is A, over the hypotenuse, which is that X value that I just stored. So now how do I find the A? Good. Multiply by the X, which is probably what Kendall did show y'all. She did. You, X cosine, that takes practice. I'm sure you did better than you think you did there. All right, so I'm getting for that little piece 478.07, but the problem said round to the nearest integer, which means a whole number. So you guys should put 478. People at home, what questions do y'all have on 5? I'm so proud of y'all for sticking on. I'm gonna make sure all of y'all get a couple extra credit points. Y'all are too, since y'all got up and explained it and everything. I'm thinking 3. I'm feeling like that's pretty generous. Sydney, y'all are good at home?
Yeah, I'm good.
All right, let's look at 6. 6, you'll see when you look at my paper later, I will post this for y'all. But I like scribbled out a couple things because I even was struggling with where to start. So 6 is very challenging. I don't think there's one that challenging on your test, but I wanted to prepare you guys just in case. All right, so 6. So we have X, Y, Z again with W in the middle. X, Y, Z, W comes down. Angle X is 55 degrees. Angle W, oh, that's not a right angle. Y'all didn't correct me.
I don't have the actual worksheet.
Oh, okay. I have some. I think they're in my office. I didn't even have time. I literally, the people in the front office were probably looking at me like I was a crackhead. I came running in with my 3 bags, like just running down the hallway.
They were probably like, that was one day.
Yeah, they probably thought I was a kid, honestly. All right, 82, 55, and this is 9.7. Okay, this is what they gave you an angle or triangle, problem number 6. Lord Jesus, I'll get it together at some point. All right, this is what they gave you in problem number 6. We are looking for this piece right here, WY. Any ideas on how we can get started? What'd you do, Kendall? Josh, you want to go? Let's let Josh go for extra credit. Right here?
Well, no, I was gonna say down here. Yeah, you could do that too, but for seeing
That one. Got you. I was just not following which one. Good. So Josh said he did 180 minus 82 and got this base angle. So what'd you get for this one, Josh? 98. And then why did you do that? Where'd you go next? Perfect. So he did that so he could find this top angle right here of 27 degrees. So correct me if I'm wrong. I'm thinking this is why you did it. So Josh looked at the picture and said, okay, I need to figure out a way to set up a proportion to find something in this right triangle right here because we're looking for this question mark. So he's trying to set up a proportion to find one of these 3 sides. The side that he saw was attainable was this diagonal one, correct? Is that what you did? Perfect. So he found this side first. I'm going to call this X. So listen to me very carefully. You want to try to find the side that somehow connects to the other triangle. That's going to be the easiest one to attain. So do you see how both of these smaller triangles share that middle side. Does everybody see that? Yes. Okay, this one's hard, so I need to make sure you understand where I'm coming from. Josh, very good job. So Josh said he wanted to find this side first. So right here, we know this is a straight line. It should add to 180. So he did 180 minus 82. And then we know this smaller triangle right here should also add up to 180. So once he got this was 98, he found this one was 27. You did it an easier way than me. All right, from here, did you, Josh, do sine of 27 over 9.7? Okay, sine of 27 over 9.7 equals sine of 55 over x? Perfect. Yeah, I actually did it a different way. There's more than one way to do these. His way is going to be a step shorter than mine, though. I'm going to pause for a second, see if anybody at home has a question. Or anybody in class. Kayla, does that help with the first step? Okay. All right, so what do we do from here, y'all? Good, cross multiply first. So x times sine of 27 equals 9.7 sine of 55. And then Cody said we got to get x by itself. So Cody, do you agree we would divide by sine of 27? Fantastic. Do y'all need to see me type that in Desmos, or are y'all okay if I keep using a calculator so I don't have to switch screens? Calculator son? Okay. So we're doing 9.7 sine of 55. I'm going to put that all in parentheses, because that's the numerator. Divided by parentheses of the denominator, sine 27. So I'm getting for x 17.50, but what do I have to do with that? Good, store it, or if you're using Desmos, save it. Don't get rid of it, because you need that whole number to plug into the next part, okay? All right, so I'm saving that. So I'm gonna hit store as x, and it is stored. So from here, now we know this piece. We know this little blue triangle is a right triangle. Now I have an angle and a side, which means I should be able to use SOHCAHTOA to find this other one. And if you guys look at the angle that I gave you, we want the adjacent. We know the hypotenuse now. So this is also going to be cosine. Good job, y'all. I'm so proud of y'all. I called my husband crying. He was like, breathe. Like, it's your pre-cal kids. It ain't your math one kids. They'll be okay. And I was like, oh, you're right. All right. Cosine of 82 equals whatever we're trying to find, which is right here, over that x value that I just found. So how am I going to get the numerator by itself? Times x again. So if I do that x value times the cosine of 82, let's in the sense that people at home can see, I'm getting 2.44. And it said round to the nearest 10th place, so 2.4. Does that help? Okay. I'm going to show you before y'all pack up. People online, y'all don't go anywhere, because if y'all need me to do more, I can do it during my planning with y'all. I do want to show you, I did it a different way, kind of. Actually, no, I didn't, Josh. I did it the exact same way you did, JK. But I started doing crazy stuff at first. I'm not, and I don't, why did I do that one? I don't know. Who knows?
I did that too.
You did that too? And we didn't even need it.
I was trying to do the way I did the baseball thing and find the angle and then do like that entire side minus 9.7. And I was like,
Okay, for number 3, does everybody agree that they gave you side, side, side?
Yes.
Okay, so if you draw number 3 and you set it up and you look at the picture, so 2 goes with angle A, 3 is angle B, and side 1 goes with angle C. So if you look at this picture, there's no way you could use law of sines because you wouldn't be able to set up a proportion. You would have sine of A over 2 equals sine of B over 3. You'd have two unknowns. So we know we can't do a proportion, which is why with side, 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 you have to do law of cosines. So for law of cosines, we're trying to find an angle. Doesn't matter which one, but I've got 3 angles I need to find. Which one did y'all try to find first?
I tried A first.
Me too. Good. I just go in alphabetical order usually so that I don't mess something up or miss something. So the cosine of alpha, I'm using my law of cosines formula for an angle. So that should equal 3 squared plus 1 squared minus 2 squared, right? Minus 2 squared over 2 times 3 times 1. Is that what y'all got?
Yes, ma'am.
Okay, so then to find alpha, Ross, how do I move that cosine over?
You have to do the cosine inverse.
Very good. So if you do the cosine inverse of that quotient right there, let me see if I brought my calculator. I'll just use Desmos so y'all can see what it'll look like in Desmos too on this video. All right, so I'm going to go to functions, cosine inverse of 3 squared plus 1 squared minus 2 squared over, ooh, we talked about this the other day. You have to like write it twice or put it as a fraction for it to let you do it. Over 2 times 3 times 1. All right, and what are we getting for the angle?
0.
0. So even if you accidentally left this one in radians, because I think I did. I sure did. 0 radians and 0 degrees is the same thing. It basically means there's no angle. If angle alpha is 0, then that means I don't have this third angle over here. So basically what this means is instead of a triangle, we just have a straight line.
So can a straight line have like 0 degree?
There's no third angle, Ann. So this angle doesn't exist. So all you have are these two pieces right here. So it's just a line segment. This doesn't exist. So basically, you see how you have 1, 2, and 3? Ann, you see how you have 1, 2, and 3?
Yes.
Okay.
So a line cannot have 0 degrees, so that's not existing.
No. Look at what I'm drawing. So basically, the whole thing all together is going to make 180. This part right here just is not an angle. I put it in the wrong spot. 1 should be over here. 1 and 3 in between those is no angle. It makes a straight line. If you get one of the angles is 0 degrees, all you have is a straight line. Okay? This is not on your test tomorrow. I just wanted to show you on the review what you would write if you got 0 degrees from one of the angles. Let me draw this better because I know you're about to tell me that doesn't make sense. All right, 2 should be in between 1 and 3.
Yes, Paul.
Hang on, Ross. Let me draw this. 2. I drew that right. Y'all were looking at me like that didn't make sense. So angle B and angle C, these two angles right here, this would be B and this would be C. Those together are going to make 180. Angle alpha is 0 degrees in between 1 and 3. There is no angle there because we got 0. So basically this makes a straight line, which means there is not a triangle. So all you would put for this one is no solution or not a triangle. But again, I don't think there's one of those on your test. All the ones on the test that I picked should work out good. But they usually have one like this on the exam. So I wanted to throw that in there so you guys could see it. As long
Miss Poole,
hang on, as long as you don't get 0 degrees, then once you find the first angle, you can do law of cosines again to find the second one, or you can do law of sines and do a proportion to find the second one, right? As long as you don't get 0. So let's say we didn't get 0, let's say we got 20. Then you can set up a proportion to find beta, and then once you have these two angles, you can just do what with them to find gamma?
Law of sines.
Nope.
Subtract them from 180.
Good. Subtract them from 180. Good job, girls. Once you do law of sines, Ross, and you find beta, and you have beta and alpha, you've got 2 of the angles. So just subtract them from 180 to find the third one.
I didn't hear you say if you had like the 2 angles.
Got you. Yep. All right. Now I will take questions.
So I know a line has like 180 degree. So can it have 0 degree?
So look at my picture again. When you get 0 degrees, basically what that means is there's no angle between 1 and 3. Those are the end points of the line segment. They don't form an angle. B and C together will make 180 degrees. Look at this picture right here. That's what these 3 measurements would look like.
Okay, thank you.
You're welcome. Who else? I think somebody else had a question. Ross, you
I
good?
found C, and I also got 0 for C.
Yeah, I had done the same thing. I had gotten 0 for A and B and then 180 for C.
So you might have drawn your picture different than me, potentially. But again, there's not one like this on your test. So I don't want you guys too concerned about it. Just know if you get one of the angles is 0 degrees, then it does not form a triangle. It's a straight line.
So we would just put no solution.
Exactly.
Already.
All right. Everybody's okay with 3 now?
Yes.
Okay. KJ's sitting at home like, Lord Jesus, I just wanted to see number 7.
That's good. I looked at that one and I got 180 for one of the angles, and I was just like, this doesn't make sense. I just put no solution. I was like, that doesn't make sense.
Right. It is no solution. So you got something that made absolutely no sense is no solution. Good. That's my whole goal for y'all in pre-cal is if we get something that doesn't make sense, we should be able to process through it and realize why it is no solution. All right, for number 7, this one's not bad, but a lot of y'all looked at your reviews, you drew your pictures wrong, so that messed up your trig. So a straight trail with a uniform inclination, which means it's on the same incline the whole hiking trail, leads from a hotel that's at elevation 5,000 feet. So here's the hotel. It's at 5,000 feet. And the trail will go down to a valley that's at an elevation of 4,100 feet. So I'm going to put that right here. So that's the valley. And the hotel is at 5,000. So if we know the hotel is at 5,000 feet and we know the valley, the elevation of the valley is 4,100 feet, can somebody tell me what we know the height should be?
900.
Good, KJ. The height is 900. We don't know the horizontal distance, but we do know the length of the trail. How long was the trail?
Wait,
4,100.
Miss Poole, why was it 900?
Why is the height 900?
Yeah.
So the elevation is another word of height. So think about if you're at the mountains. I was just in the mountains this weekend. So if we're staying in a hotel that is at elevation 5,000, and then the valley is at elevation 4,100, the difference in those heights is 900. So if I'm talking about the trail between the two,
Oh.
the heights would be 900.
Okay, I got it.
You're good. And then you guys told me the trail was 4,100 feet long. So this is the distance right here of the actual trail. All right, so the question says, are y'all okay with this picture?
Yes.
Okay. I'm gonna move so y'all don't hear that. Okay. Sorry. Okay. So what is the inclination of the trail? They want to know the incline. The incline would just be this angle right here. We want to know basically how steep the trail is. So I'm trying to find this angle. So look at what two sides you do know. We know the opposite side is 900 and the hypotenuse is 4,100. So if I have opposite and hypotenuse, I can use
Sine.
good, KJ. Yep. So sine of x equals 900 over 4,100. And then how will you get the x by itself? How would you move the sign?
Sine inverse.
Perfect. So for this one, all you have to do is sine inverse of 900 over 4,100. So one more time, I want to explain this one because usually my kids struggle on this one. We're talking about a trail that leads from a hotel to a valley, the lake in the valley. So if the hotel is 5,000 feet high in elevation and the valley's at 4,100 feet high in elevation, the height between the two, the distance, the vertical distance, the elevation distance is going to be 900. Y'all are okay with that part?
Yes, ma'am.
Okay. And then I always have kids try to tell me that this part down here should be the path, the trail. But if I'm trying to get between the two, the trail is going to be the diagonal. All right, what questions do we have on 7? So when you do the sine inverse of 900 over 4,100, I got, sorry y'all, I'm moving. I don't want y'all to have any background noise. I got, when I did the sine inverse of 900 over 4,100, 12.68 degrees.
Yeah, I drew my triangle wrong and got like 52.
Yep. So make sure you understand how the picture is set up. That's the tricky part about these word problems. The math in them is pretty easy, but it's setting the picture up and understanding why the picture is set up that way. Any questions on 7?
No, ma'am.
Okay. All right. Now I'm gonna keep going then. So y'all said 9 and then 14. All right. Number 9, they gave you the picture. So let's see. Sightings, blah, blah, blah. How high is the bridge? So they literally gave you everything pretty much you need to know. We're looking for the height. This is just like one you had on a homework and in the notes. And it's on your test review, which means we can assume it will be on the
Test.
yeah. So they gave you the picture for this one. The one on the test may not give you the picture. Do you guys remember the one where we're talking about the 2 people looking up at the plane and the 2 people looking up at a kite?
Yes.
This is the same exact problem. It's just somebody is down in the water looking up at the bridge and they look up at 2 different sides of the bridge and they want to know how high up the bridge is. But it's the same exact problem. I just took the triangle and flipped it. So who remembers what we do first in this type of problem in order to find the height?
I found the other angle.
Good, that's what you have to do first. You got to find this other angle, but then once we find that angle and use law of sines, remember we can find either one of these sides. And then once you have one of these sides, just depends on which one you chose to do, you'll get the same answer either way. Then you have a smaller right triangle. where you'll know a side and an angle, which means from there we should be able to do SOHCAHTOA. Remember, height is always vertical. So this would be a 90-degree angle right here. So finding the other angle, Ross, how'd you find this angle down here? Because I agree with you. That's what I did. That's what you have to do.
I did 180 minus 69.2 minus 65.5.
Very good. And did you get 45.3?
Yes, ma'am.
Perfect. All right. So that's that base angle. So now I should be able to set up a proportion to find one of these sides. Which one do y'all want me to do?
It doesn't
one.
matter.
Okay, I'll do X just because it comes first. So if we do sine of 45.3 degrees over 880 equals sine of 65.5 would be what would pair it with X, right?
Yes,
Right.
ma'am.
All right. So then we would cross multiply, solve for X. Do I need to show y'all the cross multiplication or can I just tell you what I got for X?
You can just tell us.
Okay, I got 1,126.57, but you can't round it. What do I have to do with this number?
Store it.
Good, store it or save it. And so when I post my key in a minute, you guys will see that almost all of them, I wrote store/save underneath the first thing I got, okay?
I think this is where I messed up for that one because when I did that proportion, I just put that as the height and not as the X or the Y value on the side.
Yeah, so that's not the height. That's one of these side values. But now that I know this side value and I know this angle right here, this side value, and this angle right here, and I know this angle is a right angle, I can use SOHCAHTOA to find this height now. So look at the angle. I want the side opposite of it, but I know the
Hypotenuse.
hypotenuse. So if I want the opposite, Ross, and I know the hypotenuse, let me draw it over here for some of y'all. We know this angle is 69.2. I want the height, and I know this hypotenuse. Opposite over hypotenuse is
Sine.
good. So you guys should have set up sine of 69.2 equals the height over the X value that we just found. And to get the height by itself, what will I do with the X value we just found?
Multiply it over.
Good. So for the height, once you multiply it over, I got 1,053.15 feet. Does that help with 9?
I kept the first answer as my final answer, like the 1,126. I didn't like do the height and everything. I thought that was the height.
Nope. So make sure, that's the second time I've heard one of y'all say that. Make sure you really look at the picture and that law of sines, that's going to help you with the overall triangle. Because when you found this piece right here, let me erase some of this so y'all can see better. When you found this top angle, that was for the whole triangle, the big triangle, not just this little one. If you had been able to find just this little angle, then you could use just this little side in the proportion. But we found the whole angle. So that goes with the far side of the whole triangle. Okay?
Okay.
All right. So let's look at 14 and then y'all are good to go. 14 was tricky. It's actually a calculus problem. So the one on the test won't say something like this. But it says the included angle is obtuse. Basically, when you have law of sines, you can have two different triangles. We don't do that in pre-cal anymore. We used to. They took it out this year. So you guys will see that in calculus, but you wouldn't see something like this on my test. So I think a lot of you were getting confused because when you found the area or when you did the area formula, since they gave you the area, you guys were getting an acute angle, weren't you?
Yeah.
So I got an acute angle too, and I wrote down like, this is actually a calculus problem, blah, blah, blah. I should have looked more closely when I made y'all's test review, so that's my fault. But the area of the triangle is 6. We know the two side lengths are 2.8 and 7, so 2.8 times 7. And then it says the included angle is what we're looking for. So we don't know the angle. So all you had to do was multiply 1/2 times 2.8 times 7, and then divide it over, and that would equal the sine of y, and then you'll take the sine inverse to find the actual angle. Does anybody need to see me do that? Or that's what y'all did and you just were getting an acute angle, so you were confused?
I didn't even know you do that. I drew a whole triangle. and
You can
everything.
draw- I drew a triangle on my paper too, Ross, but it tells you that two sides are 2.8 and 7. And then it tells you the included angle is obtuse, but it doesn't tell you what it is, so you can make it x. And it gives you the area. So you just need to know your area formula takes two sides and the angle in between them. Multiply the two sides, divide it by 2. That's our area of a triangle. And then take the sine of the angle in between them, because that would give you the height.
Yeah, I did law of sines and stuff.
Oh yeah, no. It's talking about area. It says the area of a triangle is 6. So this is literally just like the problems we did on Thursday, but I'm having you work backwards. I gave you the area, gave you the two sides and their included angle, and I'm asking you to find what that angle should be. Does that make sense?
Miss Poole,
Yeah, Sid.
did you say take the sine inverse of it?
Oh yeah, so watch. I'll solve it for y'all.
Because I got undefined when I did that.
So that's okay. Did you multiply 2.8 times 7 times 1/2?
Yeah, but I had divided it. Divided it over to the
Right.
other side.
So this is, if you multiply those three things, it's 9.8. So then you divide it over. So that would be 6 over 9.8 equals the sine of y. Y'all got me saying y. That's angle gamma, C. So the sine of C. So then how do you get C, angle C, by itself?
You divide it over sine inverse to the other side.
Sine inverse. So I need to take the sine inverse of 6 over 9.8. So once you do that, I got 37.8 degrees for the angle.
Okay.
Does that help?
Yes, it does.
Awesome. Any other questions, y'all?
I thought an obtuse angle should be like greater than 90 degree.
And you weren't listening.
Sorry, I thought
It's okay. So basically, this is a calculus problem. So when you do area of a triangle, it comes from the law of sines, which we talked about last week. And with law of sines, you can actually end up with two different triangles. If you want to come to office hours so I can show you that, you can. I should have never picked one that said obtuse. This really should say acute, because we don't do the two different triangles in law of sines cases anymore in pre-cal.
Oh, okay.
Okay? So it shouldn't be obtuse. Basically, the one on the test tomorrow doesn't say anything about acute or obtuse. It says find the angle.
Okay, thank you.
You're welcome. What else, y'all? Any other questions? I'll put my key on Canvas so you can look at it. I got office hours today, 3 to 4. So if you have other questions you think of, you can pop in then and ask them. And then I also will have a class Zoom tomorrow at 9 in case you have any other questions. And in that class Zoom, I'll go over the quiz also.
Okay.
Okay?